Okay, now next point is the we have to design the truss now. So design of roof truss. Design of roof truss. So procedure, we will see first procedure and then we will solve the example. So procedure, in the procedure, step 1, write down from the span, comma, roofing material, decide type of truss. From the span and roofing material, decide span and roofing material, decide type of truss. So first we have to decide type of truss. Depend upon span 6 meter to 20 meter. That is depends upon us. Otherwise they have given in the problem statement directly span type of truss they have given. Like design a Pratt truss, design a how truss. Like this they have given in the problem statement. Or we have to decide the type of truss. Whatever type of truss we have seen 1 to 8, that type of truss we have to decide first. So that is the step number 1. Now step 2, calculate spacing of truss. So spacing of truss is equal to, so we have seen in the different terms, the spacing of truss is equal to 1/3 to 1/5 of span. 1/3 to 1/5 of span. One-third to 1/5 of span. Then step 3, calculate pitch or rise. Calculate pitch or rise. Calculate pitch or rise. So how to calculate pitch or rise? So rise is equal to again 1/3 to 1/5 of span. 1/3 to 1/5 of span. Step 1, 2, 3 over. Then step number 4, calculate slope. So slope is equal to, theta is equal to tan inverse of rise divided by span by 2. Slope is equal to, theta is equal to tan inverse of rise upon span by 2. Step 5, step 5, calculate calculate incline length, calculate incline length of principal rafter, calculate incline length of principal rafter. So incline length of principal rafter, it means what? So this is the half part of your truss. So this is the principal rafter. So this is the theta, this is the rise. So theta is known, rise is known. So we have to calculate this incline length. So how to calculate incline length? So anyone can tell me incline length of principal rafter. What is in how to calculate this length? We have to calculate. Rise is known, this theta is known. Again, this is the span by 2. Span by 2 is there again. So these all things are known. We have to calculate this. So we can calculate by two ways, because this is right angle. So rise square by span by 2 square. Again we will get the under root of this square plus this square. बरोबर का? समजा हे ए आहे, हे बी आहे, हे सी आहे. एकतर असा फॉर्म्युला यूज करू शकतो, ए सी स्क्वेअर इज इक्वल टू ए बी स्क्वेअर प्लस बी सी स्क्वेअर, या पद्धतीने काढू शकतो. ऑर इन टर्म्स ऑफ थीटा कसं कॅल्क्युलेट करू शकतो? इन टर्म्स ऑफ थीटा स्पॅन बाय 2 कॉस ऑफ थीटा, स्पॅन बाय 2 डिवायडेड बाय कॉस ऑफ थीटा केलं तर आपल्याला ही इन्क्लाइन लेंथ मिळेल. आर यू गेटिंग? स्पॅन बाय 2 or under root of, this is or under root of rise square plus span by 2 square. So by using these two ways we can calculate the inclined length of this principal rafter. By using this formula or this formula we can calculate. So step number 5 is over. Now step number 6. Step number 6 is calculate inclined length of one panel by assuming number of panels. By assuming number of panels, it means what? These are the panels. These are the panels 1 2 3. So we have to assume these panels each side. Okay, sorry for disturbance. Okay, so calculate inclined length of one panel. So we have calculated length of this whole principal rafter. So we have to assume the panels. So 1, 2, 3. So 3 panels, or we have to assume again one more like this, 4 panels we have to assume. So if we assume 3 or 4 panels in each side, so then that is the number, assuming number of panels. Number of panels means 1, 2, 3, 4, that we have to assume. ते आपल्याला अजूम करायचे आहेत. वन किती, 3, 4, 5, 6. आपण एका साईडला 6 पर्यंत पॅनल अजूम करू शकतो. सो मिनिमम so minimum 3, 4, maximum 6 panel we can assume. 3 पासून 6 पर्यंत आपण assume करू शकतो panels. Okay, so here we have to assume. So how to calculate inclined length? So inclined length of one panel is equal to inclined length of one panel is equal to inclined length of principal rafter, inclined length of principal rafter divided by number of panel. जर ह्या टोटल इन्क्लाइंड लेंथला जर जेवढे नंबर ऑफ पॅनल आपण आहेत त्यांनी समजा 4 अज्युम केले, तर 4 ने डिवाइड केलं तर एका पॅनलची लेंथ मिळणार. दिस इज वन पॅनल. आर यू गेटिंग? सो एका पॅनलची लेंथ आपल्याला मिळणार 1, 2, 3, 4. पॅनल म्हणजे काय, इथं आपण काय करणार आहे, पर्लिन बसवणार आहे याच्या खाली. सो दिस इज दी वन पॅनल. सो इफ 4 assume, so 4 purlin will be there, and if we assume this assumptions number, if we divide here, then we will get the length of one panel. This एकाची लेंथ आपल्याला ही मिळेल. Are you getting? So inclined length of one panel is equal to inclined length of principal rafter divided by this number of panels. In this way we have to calculate the inclined length of one panel. This is the step number 6. Now step 7. Step 7 is equal, now calculate dead load. Now we have to calculate dead load. Whatever dead load we have seen in the loads on the roof truss, that is the first, the dead load. So first, which type of the load is there? So small a is the weight of truss. So weight of truss W we have to calculate by using this formula, span by 3 divided by span by 3 plus 5 into 10, it is in Newton per meter square. But now it is Newton per meter square. So now we have to calculate this is in Newton. So if we have to, जर न्यूटन मध्ये कॅल्क्युलेट करायचं म्हटलं तर काय करायला लागेल, याला तुम्हाला काय करावं लागेल, प्लान एरियानं मल्टिप्लाय करावं लागेल. एरियानं मल्टिप्लाय केल्यानंतर हे मीटर स्क्वेअर जाईल, बरोबर आहे की नाही. इफ वी डिवाइड इंटू मल्टिप्लाय इंटू एरिया, देन हे मीटर स्क्वेअर निघून जाईल. ज्या एरियावरती तुमचा हा रूफ ट्रसचा लोड जातोय तो एरिया न जर मल्टिप्लाय केलं तर हा मीटर स्क्वेअर निघून जाईल. सो इफ वी मल्टिप्लाय span by 3 plus 5 into 10, this is the weight in Newton per meter square, into plan area of roof truss. Plan area of roof truss. It means, plan area means this is the inclined area. This area is the inclined area of roof truss. प्लान म्हणजेच काय, त्याला आपण हॉरिझॉन्टल करायचं, याच एरियाला हॉरिझॉन्टल, कारण का लोड कसा ऍक्ट होणार आहे, वर्टिकली डाउनवर्ड, डेड लोड ऍक्टिंग वर्टिकली डाउनवर्ड. सो दिस इज दी युअर लोड, वर्टिकली डाउनवर्ड ऍक्ट होतोय. सो वी हॅव टू कन्सिडर दिस लेंथ इन प्लान. ही जी इन्क्लाइंड लेंथ आहे ही प्लान मध्ये आहे असं आपल्याला तो एरिया कॅल्क्युलेट करायचा आहे. इन्क्लाइंड लेंथ प्लान मध्ये असलेला एरिया कॅल्क्युलेट करायचा आहे, कारण का लोड हा व्हर्टिकली डाउनवर्ड जातो. इन्क्लाइंड एरियावरती लोड ऍक्ट होणार आहे का, तुम्ही एखाद्या इन्क्लाइंड सरफेसवरती जरी उभा राहिला तर लोड ऍक्ट होताना व्हर्टिकली एक्झॅक्टली डाउनवर्ड जाणार आहे. तो काही इन्क्लाइंड लोड ऍक्ट होत नसतो आपला. आर यू गेटिंग? आपण कसं उभा असतो, दिस इज दी आवर पोझिशन, ही आपली पोझिशन असते. सो द एरिया इज इन्क्लाइंड बट वी आर वर्टिकली डाउनवर्ड. सो द लोड इज ऍक्टिंग इन दी ऑन दी प्लान एरिया. या प्लान एरियावरती दिसताना जरी एरिया हा इन्क्लाइन असला तरी लोड ऍक्ट होताना हा प्लान वरती जातो, प्लान एरियावरती जातो. सो हियर प्लान एरिया ऑफ द रूफ ट्रस, plan area of the roof truss we have to multiply. So how to calculate plan area? So plan area of roof truss is equal to plan area of roof truss is equal to span by 2. How to calculate span by 2? This is the total span, so this span by 2 into spacing of truss. Into spacing of truss. Plan area is nothing but this span by 2, it means this length, span by 2 into spacing of truss. Okay, so now, so if we this plan area, if we multiply by this area meter square, so this meter square get cancel and we will get the values in this Newton. हा जो वेट आहे ते कशामध्ये मिळेल, न्यूटन मध्ये मिळेल. ओके, नाउ दिस weight of truss is over. Now small b, weight of purlin. So weight of purlin is equal to, so we have to assume weight of purlin. So weight of purlin we are generally assuming from range how much, so 80 to 120 Newton per meter square. So if this meter square is there, आपल्याला हे न्यूटन मध्ये कॅल्क्युलेट करायचं असेल तर 80 to 120, that depend on you. You have to assume 80, 90, 100, 110 or 120. याच्यापैकी कोणती एक व्हॅल्यू तुम्ही घेऊ शकता. न्यूटन पर मीटर स्क्वेअर into again plan area, plan area of truss. So again plan area of truss, how to calculate? This is span by 2 because this is the whole your panel is there. So on this panel these purlins are placed, so we have to calculate this plan area by using this formula again, plus span by 2 into spacing of truss. Okay, so now again see weight of roof covering. So weight of roof covering, is the weight of sheet. कुठली sheet सांगितली असेल ती sheet, weight of sheet into again plan area of truss, and small d, fourth type of weight of bracing. Weight of bracing is equal to, here again weight of bracing. So we have to assume how much we have to take. So weight of bracing into again plan area of truss. So this weight of bracing is in Newton per meter square. This is also in Newton per meter square. So if we multiply this plan area, then it will be in Newton. So now total dead load is equal to what? A plus B plus C plus D. A plus B plus C. So this is the total load is in Newton. Total dead load is in Newton. Okay, so in this way we can calculate the dead load. So now this dead load is acting on a panel points. So here this dead load we have to calculate dead load on each intermediate panel point. See, first intermediate panel point is equal to total dead load divided by number of panels. So dead load on each intermediate panel point, so that I will show you which is intermediate panel point, and here we have to calculate dead load on each end panel point. So panel point I have shown in figure, which is the panel point below the purlin, the point is that panel point. So dead load on end panel point is equal to dead load on intermediate panel point divided by 2. So how to act this dead load? So I will show you intermediate panel point and end panel point. If this is the truss, if this is the truss, and here this dead load is acting. So these are the intermediate panel points. Intermediate panel point. These internal are the intermediate panel points, and these two are the end panel points. End panel point. So this is the end panel point, this is the end panel point. it means the whatever load is coming on this principal rafter, so half load of this part and this part is coming on this point. So this is the intermediate panel point. So this side half load and this side half load is coming on this member, and this end panel point only this half load is coming. Are you getting? So here dead load on each intermediate panel point, म्हणजे जो काय total dead load होता, total dead load as a number of panels. So this is one panel, this is 2, 3 and 4 and 5. These are the 5 panels. If I divide this number of panels 5, total dead load divided by 5 केलं तर काय होणार आहे, या प्रत्येक पॉइंट वरचा तुम्हाला लोड मिळणार आहे. Are you getting? This total 5 panels are there. So total dead load divided by number of panels will get the value of each. These are the intermediate and these are the end. This is again end. कारण का या अर्ध्या एरियाचा फक्त इथं लोड जातो आणि इकडचा अर्धा आणि इकडचा अर्धा प्लस इकडचा अर्धा, इकडचा अर्धा इकडचा अर्धा हा फुल लोड इथे येतो आणि शेवटचं जे आहेत एंडच्या फक्त अर्ध्या पॅनलचाच लोड जातो. म्हणजे हा एक पॅनल आहे. सी दिस इज द पॅनल, हा पॅनल आहे, इथं तुमचा पॉइंट आहे, हा पॅनल पॉइंट, हा पॅनल पॉइंट. सो द हाफ लोड ऑफ दिस साइड, हाफ लोड ऑफ दिस साइड इज नथिंग बट हियर इंटरमिडिएट पॅनल. आणि जर हा एंड असेल तर फक्त या पॅनलचा अर्धाच लोड इथे जातो. सो हियर वी हॅव डिवाइडेड डेड लोड ऑन इंटरमिडिएट पॅनल पॉइंट डिवाइडेड बाय 2 इज द dead load on each end panel point. Are you getting? So here intermediate panel point, dead load on each intermediate panel point and dead load on each end panel point. So that dead load we have now here calculated. So dead load calculation is now here over. Are you getting? So how to calculate total dead load we have calculated. So from this total dead load, the dead load on each intermediate panel point and dead load on each end panel point. So मधले जे आहेत ते intermediate panel point, कडचा आहे तो end panel point. Are you getting? So on each panel point we have calculated. So here dead load on intermediate panel point is total dead load divided by number of panel. जेवढे काही number of panel आपण assume केलते ते डिवाइड केले की या मधले जे panels आहेत त्याच्यावरचा dead load येणार डाउन vertically. So this is your dead load. And this is dead load by 2. Here again dead load by 2. So this is DL. Okay. So in this way we have to calculate the dead load. So okay. So other load calculations we will see in the next lecture, because our time is now over. So in this way, so this figure is required in the examination also. So show this figure again. So this is the your dead load. Okay, I have taken attendance. Please show this figure. So this is your dead load. Okay, so our session will be closed. So okay, so we will meet in the next lecture with the calculation of the live load. Dead load calculations are over here. Okay, you can left. I have taken attendance.